Welcome back to another video from Lord Gizmo. Today, we're teaming up again with the incredibly skilled BKS Creative. But this time, we're building something different, a customized water jet boat from scratch. Like all great builds, it starts with precise planning. He begins by marking a center line on the board, the backbone of the layout. Then, using flexible wooden strips, he shapes a smooth curve across to give it shape, like the front bow. This curve doesn't just give the boat a sleek profile, it helps it glide better through the water. Every mark and measurement matters here. One wrong cut, and the whole symmetry falls apart. This isn't just slicing through the wood board, it's crafting the boat's foundation. Now, he can stitch the cut-out edges of the wood board together. This temporary stitching technique helps form the exact curve needed for the hull's shape. Next, some flat wood planks are glued to the mold. These act like braces, keeping everything locked in position during the build. Now, before we move on, let's take a moment to talk about the talent behind this build, BKS Creative. This isn't your average DIY channel. BKS has turned backyard boat building into a true art form. From fiberglass hulls to fully functional jet propulsion systems, every build is practical, precise, and seriously impressive. If you're into hands-on engineering or just love watching things come together from scratch, you need to check out BKS Creative. We've linked their channel below. Trust us, it's a deep rabbit hole of awesome builds. A similar support is added to the rear cutout area, giving it structure while he works on the sidewalls. With the wooden skeleton in place, the basic frame is ready to flip over. Before any fiberglass is laid down, he applies a smooth layer of gel coat to the mold surface. This gel coat acts like a barrier. It fills in the wood grain, prevents the resin from sticking to the mold, and gives the final hull a clean, glossy finish. Once it sets, the fiberglass layers can be applied right over it, bonding securely to form a durable outer shell. Once resin is applied, the fiberglass begins to cure into a tough, durable shell. Once the fiberglass has fully hardened, he carefully removes the wooden mold from inside. What's left behind is a clean, solid hull. Lightweight, yet tough enough to handle serious power. Now it's time to cut out the opening for the thruster tunnel. This part is critical. It needs to be precise so the tunnel fits snugly into the hull. After trimming, the tunnel is bonded into place using more fiberglass and resin, forming a seamless connection with the body. Next come the plastic structural ribs. These might look simple, but they add serious strength. Once glassed in, they stop the hull from flexing under pressure or weight. In this method, a PVC pipe is cut lengthwise to create a half-pipe shape, which is then installed over the corners of the boat frame. The half-pipe is securely fastened by drilling through the boat's outer wall and attaching it firmly to the frame underneath. This smart solution significantly enhances the durability of the boat frame, providing structural reinforcement. With the hull taking shape, it's time to focus on how this boat will move. First, he attaches two small pieces of wood to the inner bottom, using fiberglass and resin. These will serve as anchor points for mechanical components without piercing the hull. Next, he installs the pulley bracket. This is where the power transfer begins. The pulley is secured tightly so that it can handle the tension of not one, but two drive belts. These belts connect directly to the motor shaft, creating a simple but effective belt-driven propulsion system. Every bolt is tightened with care. If the alignment is off by even a few millimeters, it could cause serious vibration once the engine fires up. He positions the pulley and motor just far enough apart to keep the belts tight. Too loose, and the power slips. Too tight, and it strains the parts. With the lower hull reinforced and the drive system in place, it's time to shape the top of the boat. He starts by marking and cutting a wood board for making the deck mold. These pieces need to align perfectly. Any gaps will cause issues when resin is applied on the fiberglass over it. Once the pieces are cut and fitted together, the deck mold is ready. He begins fiberglassing by laying down the first layer along the surface, soaking it with resin to form a strong outer shell. After that, he adds a clever touch: half-cut PVC pipes, shaped like half moons, laid across the surface. These act as internal ribs. Because they're curved and lightweight, they sit flat against the fiberglass and blend easily into the deck's shape. When the next fiberglass layer is laid over them, it forms a strong sandwich structure, adding serious stiffness and preventing flex without adding much weight. With the ribs locked in, He finishes the top layer of fiberglass and resin, sealing everything together into a single, solid composite shell. After letting everything cure properly, the fiberglass deck is removed from the mold and carefully aligned with the rest of the boat. This top shell will now be bonded into place, sealing the structure and bringing the boat's shape one step closer to completion. Now that the deck is joined with the rest of the frame, it's time for the finishing touches. First up, paint. He uses masking tape to split the surface cleanly, allowing for two-tone color without messy overlap. Once the paint dries and the tape comes off, the colors pop. Lime green sweeps across the body, framed by bold black accents along the edges. It gives the boat a sleek, aggressive look that makes it stand out from the shoreline to open water. Now for something clever. He adds a metal grid under the thruster tunnel. This serves two key purposes. It keeps debris from entering the tunnel, and it helps maintain the hull's shape, reducing drag when the thruster isn't in use. The water jet thruster is the real heart of this build. It works by drawing water in, accelerating it, and blasting it out to generate forward motion. With no exposed propellers, it's safer and more compact, perfect for shallow or narrow waterways. He installs the shaft coupling to link the motor directly to the thruster. Then comes the nozzle and deflector ring. This pivoting ring controls the boat's steering by redirecting the water jet left or right. A steel cable runs all the way to the front, where the steering controls will be mounted. The engine is finally ready to meet the rest of the system. He bolts it into place, lining it up precisely with the drive belts and ensuring everything rotates smoothly. With the engine installed, he adds a driver's seat, a simple frame with solid back support to handle the boat's sudden bursts of speed. But before heading to the water, every component gets a final check. He tests the belt tension, inspects the fiberglass for leaks, and confirms the steering cable moves freely from end to end. Any misalignment here could ruin the power transfer or wear the belts down too fast. Now comes the moment of truth. As the boat hits the water, the engine roars to life. A stream of high-pressure water shoots from the nozzle, and just like that, it glides forward like a rocket. The boat zips through turns with pinpoint control, proving that the water jet system works exactly as planned. Compact, fast, and expertly built. This is the power of a DIY water jet boat done right. What did you think of the build? Drop your thoughts in the comments. And if you love this kind of craftsmanship, check out BKS Creative for more hands-on projects just like this one. Don't forget to like, share, and subscribe. We'll see you in the next one.